Alright, you guys, let's finish up those notes from Friday. Okay, so a couple things we want to know is if a function's even or odd, because then it's going to help us a lot when these problems get harder. So remember that an even function is symmetric with respect to the y-axis. So let's say I have some function like this, and it's even, and I'm trying to find the area underneath the curve. Okay, and just for the heck of it, let's say that this area, just on this right side, let's say that that area is 8. Okay, and let's say that this is 3 and this is -3. Okay, so we know that from 0 to 3 of f of x dx is 8. Okay, if the function is even, then we automatically know that from -3 to 3, it's going to be 16. Okay, so just keep that in mind. Sometimes you might see us do something like we're trying to find this. So sometimes maybe we're trying to go from -3 to 3. And you might see a teacher, or you might see me, actually in BC we do this a lot, going, I'm going to do this. Okay, so I get rid of that. And again, there might be some pretty complicated functions, and it's just a lot easier for us to do over the small interval versus the large interval. Okay, now odd functions also are interesting if we notice them. And remember that these guys are symmetric with respect to the origin. Okay, so let's say that I have some graph here, and that I know that it's odd. And I'm just going to make something real simple here. And maybe that this is -3, and this is 3, and we're finding the area. Okay, well in this case we know positive area, negative area. So if I know for sure that f of x is odd, and I know that the distance, oops, I should put it right here, that the integral from 0 to 3, if I know that that's 8, then I know that this is 0. Because if it's symmetric, then these two would always cancel each other out. Okay, so just kind of a nice thing to recognize, and it'll come up more as we move on, but we've got it in our notes for now, and it's something that we can start looking for. Okay, so let's look at how we can evaluate a definite integral using geometry. Now, we've pretty much already been doing that, but this time we're not going to be given the graphs. Okay, so let's say I give you an equation, or I should say an integral. So I'm saying I want you to find the distance under the function from 1 to 4 of x plus 3 dx. Okay, so now with these, I will want you to make a little sketch. And it just has to be a sketch. Okay, x plus 3, that's just a linear equation. We cross at 3 somewhere. Okay, looks like that. And I want the area from 1 to 4. Okay, well, I can see that that's just a trapezoid. So I would need the coordinates of these points right here. Let's see, if x is 1, then this would be 4. And if x was 4, this would be 7. Okay, so I have a trapezoid. So I know that the area is 1/2 base 1. Okay, so here's the bases. Remember, here are the bases. Remember, the bases are parallel to each other, so sometimes these things flip around and they look like that. Okay, I always just, where are the bases? They're right there. So this happens to be the height right here. Okay, so I know that base 1, it was here. It went from 0 to 4. Base 2 went from 0 to 7. The height is this distance right in here. So I have 1/2 11 times 3, which is going to be 33 halves. Okay, so when you're doing these types of problems, I do want you to make a little sketch. I want you to show me where you got that from. Okay, let's say we have something from -2 to 2, and it's the square root of 4 minus x squared. Okay, so this is the one that I really wanted you to see, because we don't have that much experience, I don't think, based on the pandemic and where you guys got through on pre-calculus last year. I am pretty certain that you guys did not do any of the conic sections. We did do some circles in Math 3, so you might have some memory of doing circles. Okay, so what I want you to know, or remember, is that the equation of a circle looks like that. And you want to put this in your long-term memory. So if you need, one of these little, note cards to put that down on and say, okay, I need to know the formula of a circle, go ahead and do that, because that's going to be an important one. Okay, if I wanted to solve for y, I would have y squared is r squared minus x squared. Okay, so y would be plus or minus the square root. Now, this one's not going to be a function. Okay, so kind of keep that in mind. But there's our r squared, so this is a circle right here. And it's only half of a circle. Okay, because the top, like if I did this, r squared minus x squared, I would get the top of a circle. And if I had the negative of r squared minus x squared, I would have the bottom of the circle. Okay, so we only have half of a circle, but this is one that I want you to recognize. And we know that the radius of that circle is 2. Well, excuse me, I should say the radius is 4. No, r squared is 4, so the radius is 2. That's right. Okay, so we're still on number 2. So I know the radius is 2, and I have the top half. And I'm going from -2 to 2. Now, the top half itself is a function, because I don't have the bottom right in there. I can see that it's symmetric as well. So let's do it both ways, just so we can see what would happen. Okay, so if I wanted the area under here, I could say that I'm going to go 1/2 pi r squared, radius is 2, and then I have to take half of that, right? Because it's half of a circle. Or no, wait, I already put the 1/2 in. Pi r squared is the area of a circle. So this would have an area of 2 pi. Okay, so let's say that we did it the other way. And we said, well, wait a second, you just taught us that this was symmetric. We could just go from 0 to 2 of that circle of, what was it, 4 minus x squared. And we would only find 1/4 of it. And so now I have 1/4 pi r squared. So that would give me pi. And then I would multiply it by 2, and the area would be 2 pi. Okay, so you can see how that works. Sometimes, we use this, and sometimes we don't. This is not a super, when I say symmetry, this was not a super complicated problem. We are going to see later on that we're going to have problems that have these like weird looking shapes. Let's see, I think I can do it. and they're kind of complicated to work with. And so we found that, you know, if we just work with one of them and it's symmetry, then that makes life a lot easier. Okay. Okay, so that was the main one that I wanted you to see. Okay, let's look at a couple more. Let's see how much time. I don't want to use up too much of your time. Let's say I have from -2 to 4, and I have the absolute value of x plus 3. Now, I like this particular problem because it has an absolute value figure in there. Absolute value gives students a lot of trouble a little bit later on in calculus, and I want you to look at why based on just a very simple graph, because if you have a visual in your head, it's not so bad. Okay, so this is the square root of x, which is a v, and it goes up 3. So let's say we're at 3 right there. And then it goes like that. And let's say, okay, so we want from -2, let's say that's -2, and let's say this over here is 4. Now, what we would end up doing if we didn't have a picture is we'd have to look at absolute value and go, you know what, you really have to do 2 different integrals. You'd have to do this side and this side. But that's just coming down the pike. But I want you to think about how absolute value really changes the way that it looks. Okay, so on here, we're going to do the same thing. We're going to do that plus that. Okay, find each piece right there. It's not symmetric, so I mean, because this side's longer. Okay, so over here we have a parabola, or excuse me, a trapezoid, right? So its height is 2. This base right here is 3. This base right here would be 5. So I've got 1/2 base 1 plus base 2 times the height plus 1/2 base 1 base 2, this would have to be 7, and its height is 4. Okay, let's see, this would be 8 plus 7, the area on this one would be 15. Okay, I think I'm going to run out of time. Let me see if I can just really quickly just show you. And again, this is just so that you have a little bit experience seeing something like this. So I'm going really quick here. This is a cube root function, and I know what it looks like, and it's going from -4 to 4, and I know it's symmetric to the origin, and I know that those would cancel each other out. So because it's an odd function, I know that the area is 0. Okay, so now you should be able to finish up the rest of that worksheet, and I'll get an answer key out to you. All right, see you guys.